Hey, welcome back. My name is Rahul, and in the next few videos, we're going to develop an Android app from the very beginning. You'll learn the fundamentals of Android development, and you can take these concepts and apply them to build your own Android apps. I'm going to assume you have some background in programming, but you might be new to Android development. What we're going to build is a tip calculator where you can enter in a base amount, a tip percentage, and the app will calculate the tip and total amount. Keep watching so we can build this together. There are three things I want to talk about in this video. One, I want to show you the main features of our tip calculator app. Second, I want to discuss the Android concepts that we'll come across while building this. And third, I want to discuss the Android concepts that we won't come across while building this, just so that you're aware that more complicated or sophisticated apps out there will have to deal with these issues that we won't have to deal with here. If you're not interested in this overview, then feel free to skip this video and go directly to the second video in the series. Let's start with a demo of the tip calculator so we can get an understanding of the main features. In this example, I went out for a very lavish dinner and I spent $83.15 on the dinner, and I'm giving a generous tip of 24%, and the app calculates the tip and total amount. Just to make the math easier, let's change the amount to be $100 so you can see that the keyboard comes up and it only allows us to enter in numbers and decimals. Now, the tip percent is still 24, and you can see that the math adds up. The total is a sum of the base plus the tip. If I was feeling more generous, I could actually increase the tip to the maximum, which is 30, and you can see the color of the text has shifted to a brighter green, so it animated, and we changed the text to be amazing instead of great. On the other hand, if I was really unhappy with the service, I might tip 0. We consider that a poor tip, and the total is the sum of the base and the tip is nothing, so this makes sense. And finally, you can see at the bottom we have a footer which says who made the app. You can kind of personalize this to be whatever message you want. The concepts we learned while building the tip calculator are going to be the same concepts that are fundamental to every Android app. First, creating the UI. Every app needs a user interface. The way we'll do this for the tip calculator is using something called the constraint layout, which is a relatively recent addition to the Android ecosystem. Constraint layout allows us to create complex yet performant view hierarchies, and we'll talk more about what that means. But the constraint layout is going to be the view group that we use, and it contains all the other views that you saw, such as the text view, edit text, and seek bar. Second, every app needs to listen for user input. In our case, we'll have two ways for the user to input data. One, which is edit text, where the user can enter in the bill amount, and second, a seek bar where the user can indicate the tip percentage. And finally, styling and animations. Pretty much every Android app will have some amount of custom styling, and most apps will also have animations. So we'll scratch the surface of some custom styling, and we'll also have a really cool animation around changing the text color of the tip description. There's also a lot that we're not covering, and this is a good thing because it makes our app simpler. First, we're not going to cover multiple screens. Our app is a single screen, and that means that we don't have to deal with the complexity of multiple screens or multiple activities and having to deal with navigating between them and handling the backstack. Second, we're not going to be covering networking or dealing with the internet. As soon as you start to make API calls to some server, then you have to think about error handling, how long the request takes, and things like that, which we don't have to deal with because everything we're doing is local. And third, we're not going to be covering storage. There's no database and there's no internal storage that our app relies on. We're taking in user data and displaying that on the screen immediately. There's nothing to do with storage. And all three of these make our app much simpler, although you might encounter these in other apps in the real world. Once again, here's the completed tip calculator application. I'll leave a link in the description to the GitHub repository which contains my code. Let me know if you have any questions. I'm here to help as much as I can. I'm sure when you build this app and you walk into a restaurant, you're going to be super popular because this app will literally have your name on it, and all your friends will be asking you to help them compute the tip that they're supposed to pay. So I'll see you in the next video. In this video, we're going to lay out the views for our tip calculator application. In particular, we're going to lay out 8 views where the 4 text views or labels on the left will describe the contents of what is being shown on the right. the first thing we'll do is open up Android Studio. And then I have it running here. Version 3.5.2 is the latest stable version of Android Studio as of today. But as long as you're on a latest stable version, you should be fine. Let's create a new Android Studio project. And the first option you have here is what kind of starter project do you want to create? And almost always I go with empty activity. The other options are useful sometimes, but they add a lot of starter code into your project, which could be confusing. And so almost always I go with empty activity. Tap on next, and then let's name our application Tippy. The package name is fine. You can save it to whatever location on your computer that you like. Make sure the language is Kotlin, and then minimum API level, I'm setting it to API 21. Now you can tap on finish, and the first time that you build your application, this might take some time. What I like to do whenever I have a new project, the very first thing I like to do is just run the starter code. Make sure that the starter code is able to actually compile and build properly so that we know that any changes we make from here on out, we're starting from a known good place. So in order to run this starter code, what you need to do is go up to this green triangle and tap on that. And I already have an Android virtual device set up, which is an emulator, which is a Pixel 2 running API 29, the Android API 29 version. You can see I have a bunch of emulators, but 29 is fine. So if I tap on that icon, you can see that this emulator boots up, and at the bottom you can see that Android Studio is trying to build our project, and it will eventually push our simple starter code onto the app. And you can see that it worked. So we have our app called Tippy, and it shows Hello World. It's worth spending just a bit of time understanding what is the starter code that Android Studio gave to us when we tapped on the empty activity template. There are two main files that we'll be interested in. One is mainactivity.kotlin, and the other is activitymain.xml. And you can see that mainactivity.kotlin is where we are defining the activity, and all the business logic associated with our activity will go in this file. So things like being able to understand when the user has changed the tip percentage and we need to recalculate the tip in total, we're going to put all of that logic in here. One important line is the set content view, where we say r.layout.activitymain. This is referring to the activitymain.xml. So what that line is saying is the contents or the user interface, the UI of our application, is going to be defined as activitymain.xml file. Let's give ourselves a bit more room to work with here. So you can see that it's a very simple view. It's a constraint layout, that's the root element. And then inside of the constraint layout, there's a text view called Hello World. So a text view in Android, you can think of it as a label. So the user can't edit it. It's basically just a view which shows some text. What we're looking at here is a graphical way of editing the user interface. So you can drag out different text views, you can drag out buttons, things like that. This is really useful, and we'll spend a lot of time doing that. But we also will sometimes need to be a bit more precise with the changes we're making in our layout. And so for that, you can notice at the bottom, we have two tabs, the design and text tab. And so usually what I do is I'll make high-level changes in the design tab. And when I want to make more precise changes, there's actual text representation in XML for the UI. And for that, we can go into the text tab. And there's actually a shortcut to go between the design and text tab, which is Control, Shift, and then the arrow keys, left or right arrow. And so because we'll be going between these quite a bit, it's worth remembering that shortcut. Now that we have an understanding of the starter code, we can take a look at our completed project to see how we can start building the UI toward this. So don't worry about the description for the tip percentage or this footer at the bottom. We're only going to worry about the 8 other views at the top of the screen. There's 4 on the left side and 4 on the right side. All of these views are going to be contained in something called a constraint layout, which is the root element by default when we created our Android Studio project. So constraint layout, looking at the Android developer website, allows you to create large and complex layouts with a flat view hierarchy, no nested view groups. The idea is that the constraint layout lets you position views inside of it by using constraints and chaining these constraints together with other views. So this is a really powerful system, but it's also pretty easy to use. One of the reasons why constraint layout is the recommended way to create your UI is because it helps us create flat view hierarchies, as the documentation says. In order to have the best app performance, you want to limit the depth of views. Having a very deep layout hierarchy means that the Android system has to spend more time in measuring, laying out, and drawing your view, which will lead to a much worse user experience. What we're going to do is construct our UI in a single constraint layout with depth of view as 1, which is as good as you can get. There's not going to be any linear layouts, relative layouts, or other view groups inside of our parent view group. So even if you haven't actually used a constraint layout before, just based on how you think it might work, which is constraining views relative to other views, spend a moment to think about how might you construct the UI shown here. How might you position these elements relative to the other elements around it? So once you have an idea in your head, let's switch over to Android Studio and actually start building. So I'm going to go ahead and just delete all of the existing views that we've already added. So we're starting with a blank canvas. The very first thing I want to do is drag out a text view representing the top left element, which is a label for the base amount of your meal or of the amount that you're tipping on. So let's drag out a text view. I'll zoom in a bit just to make it a little easier to read. The first thing I like to do whenever I drag out a view is give it a meaningful ID name. So rather than the auto-generated one, I'll call this TV base label, TV standing for text view. And then this is a label, meaning a text view for the base amount. And then the text will make that be base. And you'll notice when we drag out the view, then there's an error saying that this view is not constrained. It only has design time positions. It will jump to position 0, 0, which is at the very top left of our screen. And so what that means is we need to add constraints so Android Studio knows how to lay out this view. So what I did there is I added a top constraint. So I'm saying how far should this text view be from the top of the screen? And instead of it being 0, I want it to be 32 pixels or dp from the top of the screen. And then I want it to be, let's make it 48 from the left end of the screen. So now you can see that the error went away because Android Studio does know how to position this element. Now we're going to do the same thing for each of the other text views on the left side of our app. So we'll have one more text view for the tip percentage, one more for the tip label, and one more for the total label. So I'm just going to drag out 3 more text views, and then we'll change these accordingly. So first, I'm going to just update the IDs. So this will be the tip percentage, and then let's make it 15% initially. The next text view will be the label for the tip label. And the text will be tip. Oops. And then this bottom one will be a label for the total. And that will be total. Okay, and all 3 of these have the same issue where the view is not constrained. And so by default, they're all going to be moved up to the top left of the screen, which we don't want, obviously. And so this comes down to having horizontal and vertical constraints for every element. Both the horizontal and vertical constraint will be based on this first element that we have already placed, the base label. So vertically, everything is going to be positioned according to the element above it. So for example, I'm going to have this one be 32 pixels below the base label, and then similarly for the others, 32 pixels below the label above it. So now you can see that, if I move this, all the others, they move relative to that text view. Now for the horizontal positioning, we want all of these to be aligned to the right side of the top view. So if you go back to the diagram, you can see that, there's a line that we can draw, and all of them are aligned to that vertical line. And so in order to do that, what we basically want to communicate is the right end of this text view, and this text view should be aligned with the end of the base label. So I actually don't know how to do this in the design tab, but this is where we can go into the text tab. So you can see the textual representation. We have 4 text views: base label, tip label, and total label. And what we want to do is add a constraint, which is saying the end of, constraint end to end of, and then give the ID of the base label. So the way you should read this is, for this tip percentage text view, the end constraint is going to be the same as the end of the text view for the base label. And so if we go back into the design tab, you can see that this did get positioned appropriately now. And so we can copy and paste this into the other text views. Now if I go into the design tab, again, now you can see this nice alignment that what we're looking for. And all errors have also gone away, which is exactly what we want. One thing I'll do just to clean this up a little bit is anything in the tools namespace means that this is something which is used for the purposes of rendering the preview, but does not actually have any impact on the actual runtime code. And so because we've actually constrained the horizontal and vertical position of each of these text views, this tools namespace actually doesn't have any value for us. So I'm going to go ahead and delete that. Then one more thing I'll do is I'm pretty big on style. And so I like to be consistent with how I'm positioning and ordering the different attributes here and how I'm positioning the caret symbols and things like that. So rather than doing it manually, one thing you can do is just use this action called reformat code. And so what I did to bring this up is just bring up the action menu. And for me, that's just tapping on the shift twice and then tap on reformat code. And you can see that it automatically changed all of this to be formatted consistently, which I like a lot more. Okay, so now that we have these 4 text views, let's do some quick modifications to make it look a bit closer to what we have in our preview. The first thing I'll do is we're going to increase the font size for all of these to be 18 SP. That looks good. And then also we are going to make all of these have a text color of black. And finally, this text view is a little bit different from the others because it's actually representing some value rather than just being a label. And so for that, we're going to bold it. Great. And so now you can see it already looks a bit closer to what we have here. Now we're going to drag in each of the widgets on the right-hand side of the screen. The first element is going to be an edit text. And so for that, you go into the text tab and you can see you have a bunch of different options for edit text. The one that we care about is a number which is a decimal. Let me drag this out and I'll show you. There's nothing really special happening here. This is an edit text. The only thing that's changing between all of these different options of edit text is the input type. So the input type here is number decimal, which is what you want because we're dealing with currencies. So let's give this a meaningful ID. So we'll call this ET base. This edit text for the base value. EMS refers to the width of your edit text. So in particular, it's actually in reality counting how many capital letter M's can you fit inside of the edit text. And the reason it's capital letter M is because M is the widest character that we have. And so this is saying how many of those could you fit in. And 10 is actually going to be a bit too much for us. We're going to make it 8. And the things on the right side of the screen, we actually want it to be even larger font. And so I'm going to make this 24 SP. And so you can see that that actually expanded it. So again, the same thing applies, right? We need to constrain this view horizontally and vertically. And actually, I don't want this to be constrained vertically to the parent, so I'm going to delete that top constraint. And I want everything to be positioned relative to the corresponding view on the left side. So each of the elements here will have a corresponding view on the right side, and that's how we'll be constraining these elements. So for the horizontal constraint, what we're going to do is make a left constraint on the edit text to the base label, and that's going to be 32 dp, so we create some distance. And for the vertical constraint, what we want is we want the baseline of this edit text to match up with the baseline of this text view. And so that is something that we'll do in the text tab. So just as a structural thing, the views up here are for on the left side. So I'm just going to leave a comment for that. And then everything below here is going to be all the views on the right side. And what we want is we want to constrain this, the baseline, and we want the baseline of it to be equivalent to the baseline of the base label. So again, the way you should read this is the baseline constraint for this edit text is equal to the baseline of this element, which is the base label text view. And so now you can see graphically that, the constraint layout is showing that there is a constraint between the base here and the base here. Going back into the completed screenshot, the next thing we'll do is drag in a seek bar, which is this widget which allows the user to kind of scrub through and select a value. That we're going to go into the widgets tab and then select seek bar. I'll give this an ID of seek bar tip. And then we'll actually hard code in the width and height just because we know what we want that to be. So I'll make the width be 200 dp and the height will be 20 dp. In terms of constraints, the horizontal constraint is easy. We just want this to be similarly 32 dp away from the corresponding left-hand label. In terms of vertical constraint, we want this to be centered vertically in proportion to the TV tip percent label. And so in order to do that, we're going to match up the bottom and the top of this seek bar to the bottom and top of the tip percent. So we can do that in the text tab. So we'll say the bottom is going to be the bottom of the tip percentage, and then the top is going to be the top of the tip percent label. And now that we have constrained it vertically and horizontally, we can get rid of the tools namespace. Let's see how that looks. Great, and you can see that, graphically we can see there's a top and bottom constraint and the horizontal constraint. The next thing is we want these two other text views for the tip amount and the total amount. I'm going to go back into the comment tab, drag out a text view, and then one more. So this is going to be TV tip amount, so text view tip amount. And we don't actually know the text ahead of time, right? That's going to be something we compute based on the base value provided and the tip percentage. So we can't, let's leave the text empty. We can't know that in advance. But this is where the tools namespace comes in handy, right? Because we do want to see what this might look like. And so instead of having a normal text, let's fill in the tools text, which is this wrench text, and we'll fill it in to be like $3.78. So now we can kind of get a better sense of what this might look like. Similarly for the total text view. So we'll call this TV total amount. We don't know what the text will be ahead of time, so we'll delete that. But we do know we want some sort of preview. 1244. It doesn't really matter what the value is, just to kind of get a better sense of what this might look like. Constraining this is going to be similar to the others. So 32 from the corresponding left-hand side label. And we want these to actually have a larger font. I'm going to make it 24 SP, similar to the edit text. And now we want to vertically constrain it, and we're going to match up the baselines of each of these to the corresponding left text view. So we'll say app baseline is going to be equivalent to the corresponding text view for the tip amount is going to be the tip label. And then we're going to do the same thing down here, but instead of it being relative to the tip label, of course, it should be the total label. And now that we have that, we can get rid of the tools namespace, which is positioning it for the purposes of the preview, because now we've actually constrained it. Great, so you can see it lines up properly. And now we don't have any of the errors showing in the component tree. So at this point, we're actually done with the basic implementation of the layout. Let's actually run the app to see what this might look like in an emulator. And you can see that, let's compare it to the completed screenshot. You can see it looks pretty similar. The next step is going to be actually reacting to changes that the user has made inside of the app. So as a wrap up, what we've done here is we've used a constraint layout, and each of the 8 views that we've put on the screen are constrained in a certain way, vertically and horizontally, in relation to another view. And this is really powerful because now, for example, I could move around this view and everything will move according to that. So that's a really nice way to lay out the structure of your UI. In the next video, we'll reference these views in our main activity to start making the app interactive. In the last video, we constructed the basic layout for our application. The goal for this video is to add the interactivity in our app. There are 2 things we want to do. If you are scrubbing on a seek bar, we'd like for this label to change and update the tip percentage to be between a value of 0 and the maximum tip percentage. And also, as you type the base amount of your bill, of your lunch or dinner or whatever, we want to take that value and dynamically compute the tip and the total. You'll notice that there's no button. So as soon as there's any change in the base value or in the percentage of the tip, we should be recomputing the value and update the text view for the tip and total. So opening up Android Studio, all the work we've done so far has been in activity main.xml to construct the layout. All the work we're going to do in this video is going to primarily be in mainActivity.kotlin, which is where we'll have all the business logic. So actually the very first thing I want to do is the seek bar. There's an attribute that I forgot to fill out, which is the max. And this is going to be the maximum value allowed on the seek bar. So by default, the minimum is 0, and the maximum, we're going to set it at 30, which means that the maximum tip that you're allowed to leave is 30%. So now going back into main activity, as a first exercise, what I want to do is I would like to be able to react to changes in the seek bar and update this text view with the corresponding value of the seek bar. So in order to do that, first thing we can do is grab a reference to the seek bar. So we'll say seek bar tip. This seek bar tip, this variable is coming from the name of the ID that we gave to the seek bar. And we're going to call this method set on seek bar change listener. And what this is doing is you pass in a class, which is an instance of on seek bar change listener. And this is how the Android system will notify you that the user has changed the seek bar. So the way we'll do this is we'll type in object, which is how you do in Kotlin, and you'll define an instance of this class. And then you'll notice that we're getting a complaint here. Object is not abstract and does not implement abstract member. So basically, this class is an abstract class, and so in order to actually implement it, we need to implement those 3 abstract methods. And the reason I know there's 3 is if you put your cursor in between the class definition and then type Control-O, you get this dialog, and you can see that the three methods. So these last two, on start tracking touch and on stop tracking touch, we actually aren't interested in these. Like, we don't really need to react to them. So I'm going to get rid of the to-dos and just minimize the body of the function. So we still need to implement them, but they'll have an empty implementation. And what we care about is when the user has actually changed the progress on the seek bar, which means that they've done some scrubbing. And the value of the seek bar at that point is going to be progress. So first thing I want to do actually is add a tag so we can kind of get notified using logging that this method has been called. And the value of the tag is going to be the name of our class, which is main activity. That's the convention I usually follow. So the first thing we'll do is just say log.i, pass in the tag, and the on progress changed, and then pass and actually print out the progress that is coming in as this parameter. So let's run the app. And let's open up Logcat. And what we care about is the app Tippy, which is called RK-Ponte Tippy. And then we only care about info logs. And in particular, I only care about messages which have the text on progress change. And I want to see that this is actually getting called when I scrub on this. Let's just see what the value is. So yeah, you can see that the value is going up as I go up. And the maximum value is 30, which is what we had just set. And the minimum is 0. So it looks good. So we are able to set that properly. So what we want to do when we get notified that the progress has changed is update the value of this text view. In this text view, we gave it a label of TV tip %. So what I'm going to say is TV tip %.text is equal to the progress, right? So we want to say progress, but this progress is actually an int. What we would like to do is we want to make it a string, and in addition, we want to concatenate a percentage sign after the integer. So the way we can do that is actually using Kotlin's really nice formatting structure. So we say $progress, which is this means replace this with the actual variable progress, which is integer, and then we can just say %. Let's try that out. So now as I scrub, you can see that we are properly updating that text view. So one of the oddities, or one of the bugs kind of, is that initially the value is hard-coded to 15, which is incorrect, right? Because the scrub is still at the position 0. So what we should do is when we first initialize the app, which is right after set content view, we want to set the seek bar value to be that progress, that percentage. So we'll say 15. And in addition, we want to explicitly set the text on the TV tip %, that label, to be that 15%. And because 15 is something that we're sharing both in this line and this line, it's the initial value, I'm going to make that into a variable. So then we don't have to keep referencing it. So let me just fill this out. So I'll say 15%, right? And now we want to make 15 into a constant. So I'll add that right below the tag, private. And this is going to be an integer constant value. So initially the progress will be initial tip percent, and then this is going to be initial tip percent as well, like that. Let's try that out. So now we should see the progress bar, the seek bar already be at 15, right in the middle. And then now this value actually makes sense. So now we still get the same behavior. In the same way that we were able to listen to changes on the seek bar, we'd like to do the same thing for changes in the edit text for the base value. So anytime the user types in a value here, we would like to get notified of that and then compute the tip and total. So the way we'll do that, going back into main activity, is quite similar to what we did with the seek bar. We added a seek bar change listener. There's something analogous that happens for the edit text. So we'll say et base, and we're going to add a text change listener. And you can see the parameter here is that it takes in a text watcher. And so we're going to create our own instance of a text watcher. And then again, you can see Android Studio is complaining because there are some abstract methods. So I'm going to say Control O to override these methods. And then go down to the text watcher, and you need to implement all three of these. But similar to the on seekbar change listener, we actually are only interested in after text change. This method gets called when the user has actually changed some text. So I'm going to remove the to-dos there and just leave an empty implementation. To get a better understanding, let's put a log statement here so that we can understand when this is being called. And in addition to logging the method name, let's also log the value. So S is the editable, which is what the user's actually been typing. Let's run that. And I need to open up logcat. So we get rid of the filter for on progress change. Let's just look at all info level logs. Like before, if we change the seek bar, you get notified of that. And then if we change the base value, you can see I'm typing in 800 and we keep getting notified of that, which is exactly what we want. Every time this gets changed, we would like to be using that as an opportunity to calculate the tip and total. So I'm going to define a method which does that for us. Say compute tip and total. And then Android Studio can help us create this function. I'm going to define it inside of main activity. And the idea is that we want to get the value of the base and tip percentage. And then once we have these two numbers, the base and tip percentage, we can calculate the amount for the tip, which is going to be the tip percent times the base. And we can also calculate the value for the total amount, which is the tip plus the base. So the value for the base is going to be whatever is inside of the base. So it's et base, the edit text, base, text, and we need to actually call toString on this. And then this is going to be a string, but in order to do math, we want it to be a double. Like we want it to be a decimal, to double. Great, and now we can capture the value of this as base amount. And then we want to get the tip percentage. So that'll be the seek bar. The progress of the seek bar is the percentage of the tip that we want. So this is going to be tip percent. And so now it's a question of just doing the math between these two values, right? So we can say the val tip amount is going to be the multiplication of the base amount times the tip percent. And then the total amount is going to be the base amount plus the tip amount. And so now that we have these two values, all we need to do is actually place them into the corresponding text view. So this one is TV tip amount and the total is the TV total amount. I want to copy the IDs and we're going to start referencing that here. So we'll say TV tip amount dot text is equal to tip amount. And then we want this to be a string. And so I'm going to say toString, and then similarly, we want TV total amount. The text of that should be the total amount toString. Okay, let's try it out. So the tip percentage is 15, and then I can type in 80, and you can actually see that the tip computation is a bit off because this is actually more than the base value. I think I know the reason why. It's because the tip amount should be the base amount times the tip percentage divided by 100, because we need it to be a percentage. So let's try that one more time. Just to make the math easy, let's put in 100. And now it makes sense. 15% of 100 is 15, and that means that the total is 15 plus 100, which is 115. That looks a lot better. One thing that we haven't done yet, though, is as I change the tip percentage, we would expect that the tip amount and the total amount should change. And the reason this isn't working yet is because we haven't called this method from the onSeekBar change listener. And so all we need to do is call this method whenever the seekbar has been changed. Let's try that now. So now if I say 100, like before, we get 15 and 115 as the value. And if I change this, you can see it does actually update properly. Awesome. So there are actually two things that I think we can really improve here. Spend a minute to think about what might go wrong or what could we improve on the current implementation. So the first thing is actually a bug. And so let me show you what the bug looks like. So if I backspace, don't have anything in the base amount, then you can see the app just crashed. If you open up Logcat, please see why. I'm trying to look at the very top of the stack trace. You can see fatal exception main on the main thread, number format exception, empty string. And so it actually gives us a pointer to where this crash occurred. And you can see that we're trying to get the value of whatever's in our edit text. We're calling toString on it, but that's an empty string. And we're calling toDouble on an empty string. And we don't know how, Android system doesn't know how to convert an empty string into a double number. So that's the issue. So what we want is we want to guard this call. And before we make it, we want to check, is our edit text actually empty? And if it is, we don't want to try and convert that to a number. So we'll say if etBase.text, and the string value of that is empty. Then a couple things we want to do. One is we want to actually update the value of our tip and total to be empty because it doesn't make sense to show anything then. And then the other thing is we want to do an early return so we don't actually execute any of this logic. So we'll say the text is empty for both the tip and total. And then we also want to return early. Let's try that. So now if I type in some value and I backspace, you can see that we don't crash. And then we've also appropriately cleared out the value for tip and total. One more thing we can do is actually we can get rid of the toString method because the value of the text, which is an editable, that actually has is empty method. So there's no need to actually call toString on it. Okay, that was one of the issues. What is another thing that we could improve? The second thing I think we can improve is the formatting of the strings. It's not obviously obvious here, but it's a little weird that, we only have one decimal point. Typically, when you deal with currencies, you want 2 decimal points. A way to make this look even worse is if I do 100.9, then it turns out the computation of that is 116 point some very long decimal. The user only cares about showing 116.04, for example, if you're rounding. And so the way you can do that is using string format. So instead of calling tip amount toString, which will just take the value of that number and convert it to a string, we want to be a little smarter about how we do that conversion. And it's pretty easy to fix it. All we're going to do is use this as our format string and call the format method on that with the amount. And so we're going to do the same thing for the total amount. Okay, let's try that. So now if I type in 100, it's similar to before, except now you can actually see we have 2 decimal points after the value. And now if I do 100.9, we are properly showing only 2 decimal points, which is a much better user experience. If you've gotten this far, you're doing amazing work. We have at this point a very functional app. And the way we've made that possible is by having this business logic in main-activity.kotlin. And we're basically listening for changes in either of the input forms, either the seekbar or the edit text. There's no submit button, so anytime a change happens, we're taking those values and combining them to calculate the tip and total. So the next step is to personalize this app and make it look really cool. We're going to have some custom styles, and we're also going to add a footer at the bottom. At this point, we've done the basic implementation of our tip calculator app. The goal for this video is to add some color and some personalization in our app and really show off our design skills. Unfortunately, my design skills are pretty limited, and so what I'm going to end up building is something that looks like this. So definitely it's an improvement over the original app, but I'm sure you can do much better. So feel free to take the concepts I show you and change the app however you want. To start with, let's add this text view at the very bottom, which is like a footer. And a lot of websites, apps have this where it says, made with love in California or made with love by this person. We're going to add a text view at the very bottom of the screen, which contains this heart emoji. To do this, let's go back into activity-main.xml, and we're going to drag down a text view. So I'll zoom in a bit just so it's easier to see. And we're going to add constraints to the left and right of the parent view, which is a constraint layout. And that will be what constrains the view horizontally. It'll be right in the middle. And then we're going to also constrain it below with a margin of 32. So this is going to be 32 pixels or 32 dp above the bottom of the screen. And we'll call this TV footer as ID. And the actual text, I'll make it say, made with love by Rahul. And of course, you should personalize it however you want. A few other things that we can do: make the font size a bit bigger, 18 SP. And then let's also make the font family sans serif condensed light, which makes it a bit thinner. And one more thing we can do is if you look for all caps, and there's a setting here, which will do that for us. And finally, we want to change the text to actually have a heart emoji instead of showing the text. Literally what I did is I just Googled for heart emoji, and the very first result, which is from Emojipedia, you can copy that. And once it's on your clipboard, you can go back into Android Studio and then update it here. And it shows up weird in the preview, but in my experience, it actually shows up properly in the emulator. Let's try it. There, you can see it looks pretty similar to what our eventual app looks like. There are two more things I want to show you in order to get to this completed sample app. First, how do you update the color and themes? And second, what I'm really excited to show you is how do we implement this text view, which is a description of the tip percentage. And we're actually going to animate the color. So as you scrub up and down, the color of that text view is going to change. First, let's talk about how to update the color scheme for our app. Going back to the project, if you open up the project view, inside of a directory called manifest, there's a file called Android Manifest. Every Android app has to have an Android Manifest file, which describes important information about your app. Things like how many activities are in your app, what permissions does your app need, things like internet or storage. And importantly for us, it also includes information around things like theming. And so there's a line here, Android theme, and it's referring to a style file. So this is style app theme. So if I go to the definition, you'll see that this is something that came in with the starter project. So if I tap on this button to see scroll from source, you can see there's already a directory called values in the resources directory called styles. And here's how Android is figuring out what color to show in the app that we have running currently, this dark green color and this pink color. That's coming from color primary and color accent. And these colors are actually defined in another file. So there's one more layer of introduction, which is why it can sometimes be a bit confusing. But if I go to the definition here, this is defined in the colors.xml file, which is also located in the values directory. If we want to update the color scheme of our app to look something similar to what we have here, we need to update these values. So I'll paste in the values that I had come up with in order to make the app look like this. But let me show you how I came up with those values in case you want to experiment with it on your own. And it can be pretty fun. So just go to color.adobe.com/create. So this is a tool that helps you pick a color palette. And the color palette is what you can use to educate the colors you pick for your primary accent and primary dark color. So for example, what we have here is different kinds of rules for how your colors should relate to each other. You have analogous, monochromatic, triad, and you can see how the colors actually change. And once you find something you're relatively happy with, you can modify it however you like by using this color picker. So going back to our app, the colors that I came up with are this orange color for the primary. And actually I use the same orange for the accent. And you can kind of see a nice preview on the left-hand side. I'll leave the primary dark as is. And so let's run the app and see what that looks like. So now the orange colors match up, but you can tell there's a bit of a shading that happens in the background. So in order to do that, we actually want to update our theme. So I'm going to add one more line here. And the attribute that we want to update is Android color background. We want to have this refer to another color that we are going to define called color background. So I'll copy that and define it in this file, the color background. And the background color that I picked is this really light blue color that's off-white. And now you can see that it matches up exactly with what the screenshot shows. The last thing I'd like to show is how to implement this text view, which has a changing text and color for the description. Here's a GIF of how it works. So as the user picks a tip percentage, if it's a very good tip, the color will be green. And if it's a very bad tip, it'll go back to being red. And then in the middle, it'll be some color in between green and red. I like this feature because I feel like it gives the user some engaging feedback on the tip that they're about to give. It's a lot more interactive than what we have currently. So going into activity main, the first thing we'll do is actually add that text view. So in order to do that, first, let's create a bit more distance, a bit more space in between the tip label and the percent label. I'll make it 48 dp, 48 pixels. And then we'll drag in a text view right below the seek bar. And we'll call this TV tip description. And the text initially will be empty. We don't know what the value should be, but we're going to utilize the tools namespace so we can at least see what it might look like in the preview. We'll have acceptable. And we want this to be constrained relative to the seek bar. And we'll have it be 8 pixels or 8 dp below the seek bar. And we want it now to be centered within this element, within the seek bar. So to do that, I'm going to go into the text tab and we'll start typing app constraint start is equal to the start of the seek bar. And then the end is equal to the end of the seek bar. And now we shouldn't need this absolute X position anymore, which is in tools namespace. Going back to the design tab, you can see that graphically we are seeing the constraints that we expect. So to the right and left, and then right below the seek bar. One more thing I'll do is just do some rearranging because I want all of the views to be kind of logically arranged, even though it doesn't really matter. But for our purposes as a developer, it's easy to logically group these together. So the TV tip description should be right below the seek bar. And then this TV footer, I consider that kind of another group of elements. I'm going to say footer views. So just as a reminder, we have the footer view, which is only this one text view. And then we have all the views on the right side of the screen, which is 5 elements now. And then all the views on the left side, which are 4 elements. So if we run the app now, we shouldn't expect anything too dramatic, except that we should now see this text, there's a little bit of additional space, which is a text view underneath the seek bar. And we haven't populated it yet because we haven't added any logic in main activity. So now let's go into main activity. And whenever we change the progress, we would like to then update TV tip description to have this potentially other string. So let's add another method here. I'll call it update tip description. And we'll pass in the progress. And this method doesn't exist yet, but Android Studio will create it for us. I'll define it in main activity. And then the parameter is going to be the tip percent. And so based on the tip percent, we want to correlate that with a string describing how good of a tip that was. In order to encode this, we'll use something called a when construct in Kotlin. So when the tip percent matches a certain condition, we will assign a value to this variable, which I'll define right above, which is called tip description. And this is going to be a string. When the tip percent is between 0 and 9, then the tip description should be poor. And when it's between 10 and 14, the tip description is acceptable. So the idea here is that based on what bucket the tip percent is in, we will assign the appropriate label for the tip description. And so once we have assigned the correct value for the tip description, we then want to update that TV tip description, that text view, to be this tip description. So let's try that now. So as I scrub, you can see that this does change value. Two more things that I'd like to do. First, you might have noticed that the description of the tip was empty when the app first boots up. And that's the same problem as what we had tackled earlier, which is that we're not actually setting anything initially. And we're waiting for the user to actually change the seek bar. So instead of doing that, let's call update tip description right here with the initial tip percentage. And the second thing I want to fix is in the layout, I want to change the font type of this to be bold, just to make it stand out a bit more. Let's run this one more time. And now we should see a value immediately. And we do, and it's bold, which is good. The last step is the cool part. We want to animate the color of this text view according to how good or bad of a tip this was. The key to understanding how the text color animation will work is through interpolation, which is really a fancy term for something which is pretty simple. If I have an imaginary map and I'm walking from position 0 in this map to position 1000, and I tell you I'm 75% done, then you would probably tell me that I should be around position 750. And what you're doing there in your head is interpolation. So you're assuming that I'm walking at a constant pace, so linear interpolation, and that would put me at roughly position 750, given that I'm 75% of the way done. That's exactly what's happening here. Every color can actually be represented as a number, as an integer. You can think of a color as a RGB, red, green, blue component, and each of those is an integer between 0 and 255. And so then our job is simply to pick the extreme colors. So we'll pick one color for the very worst tip and one color for the very best tip. And if, as a user, I enter in a tip which is 75% of the way there, which is 75% of the very best tip, then I'd expect the color to be 75% of the way between the worst and the best color. And that's easy to do because it's simply doing some computation on these integer colors. And in fact, Android makes this even easier for us because they provide something called an ARGB evaluator. So A refers to alpha, and then RGB refers to red, green, blue. And so this can evaluate, given two integer values, it'll do some interpolation for the ARGB colors. And that's exactly what we'll use to do the animation. So going into the code, this is going to be part of the update tip description method. So anytime the tip percent changes, we also want to update the color. The way we can do this is by constructing a new ARGB evaluator and then calling the evaluate function on this. This takes in three parameters. One, which is a fraction, which represents where are we on that spectrum of very worst to best color. And then we actually have to provide the best and worst color, which is start value, the worst, and end value is the best. The fraction is given the tip that the user has input, how good or bad is it? So for example, if I gave a tip of 15%, the best tip is 30, and so that's 50%, right in the middle. If I gave a tip of 25, then the percentage, the fraction that we should input here is 25 divided by 30. And so in order to do this, we're going to say tip percent divided by the maximum value of the seek bar, which is 30. So we'll say seek bar tip.max. And then this actually needs to be a float. And so in order to make it a float, we need to cast one of the numerator or denominator into a float. So I'll say to float. And now the next two parameters are the start value and end value. And here we actually need to define the colors. To do that, let's go back into the colors.xml and define color worst tip and color best tip. So you can pick whatever value you like for this. I picked a red color for the worst and a green color for the best. So intuitively in my head, red means something went wrong, something's dangerous, and so you want to indicate that the service you got at this meal was really bad. It's like something red. On the other hand, green emotes something very calming, very good. Green light means go. I'm just going to copy in the values that I had come up with. So going back to the main activity, the way we'll actually get the value for the color is using something called context compat.getColor, and we'll pass in the context, which is this. This is referring to the main activity, and then we pass in the resource ID. So r.color.color worst tip. And then again, we want to do the same thing for the best tip. Get color, and then this, and r.color. the result of the evaluation is it'll give back the object which is interpolated between these two values according to the fraction. We need to cast this as an integer because that's what the color should be. And now we can say val color is the result of the ARGB evaluator. Finally, last step is we want to update the text color of the TV tip description to be this color. So we'll say set text color and we pass in color. Let's try it out. So here's the preview. You can see that we have matched up the design already. And now the color of the description has also changed. So if we move this down, you see it becomes red. And then as I move it up, it gradually becomes more and more green until amazing. And that hits the greenest color that we have put into the system. And I do have to say, it feels pretty amazing to have done that in a few lines of code. If you've gotten this far, congratulations, you've built out a very full-featured Android app. And if this was your first Android application, definitely drop a comment, let me know, and extra congratulations to you. One of the nice things about the Tip Calculator app is that there are so many ways to extend the basic project that we just built. A few of the ideas I had were split the bill by n people. So for example, you could input 4 and then you could divide the total amount by 4 so you know how much each person has to pay. Another idea is to round the final amount up or down so you don't have some odd number of cents in the total. And finally, you could show currency symbols. So in the US, we use dollars, in the UK, they use pounds, and in India, use rupees. And so be able to allow the user to input the country that they're in and show the proper currency symbol. Just as a high-level review, we spent most of our time looking at mainactivity.kotlin, which is where we had all the business logic, wiring up, listening to changes in the edit text or the seek bar. And we also spent a lot of time in the activity main.xml to create our views. That's all I had for now. I hope you had as much fun building this app as I had showing you how to build it. If you have any questions, I'd love to help as much as possible. Drop me a comment. Don't forget to like and subscribe this video, and I'll see you next time.